Hey, everybody at home and here, don't hesitate to tell me if you see something that I'm missing. Like, hey, dude, you need to turn on the mic here. Okay. Good. Yeah, yeah, happy, happy. All right, good. So, the next thing we'll try is the pen, but all right, it is 8. I'm not going to close up. I might usually, but I don't want to discourage anybody from coming in if they want. I am Eric Crisp, doing this for the first time at Bubba. So, oh wait, should I be aware of the microphone? I don't know how well they can hear me if I get out there. I will get away from the microphone. If you guys can't hear me at home, then somebody say so. Somebody type something so that I know if we can hear. Something shows up in the text. You have a, what's it? Is it squeaky too? So you guys at home know on Thursday, the front table on the south side of the room is squeaky, apparently. So there was a text. All right, cool. I don't know how I'm going to work going back and forth here. Let's see. Why would I want to do a Windows 10 review right now? No, I don't want to. Well, what do you expect out of probably your first college chemistry class? What do you expect? What are your thoughts? Anything? Right? Open book. Like, I don't know what I expect. Yeah? What else? Other thoughts? Anybody? Okay. All right, cohorts. So I think then everybody here today is silver cohort, right? Yes, everybody got that message, okay? And the blue are online for right now. An important part of that I wanted to make sure folks understood was if you're not in person, do still come at 8 o'clock to the online version. I had to make some decisions about how to pace the course. There's a tremendous amount of stuff in this course. So I couldn't really afford to do the same lecture again on Thursday. It shoves too much in and too much stuff gets not explained. So Tuesday and Thursday will be different material, okay? So we'll have to talk about what happened on the day that you were out and whether or not you got your questions answered each day, too, okay? My plan is to have you partner with someone from the other cohort. There's a discussion board that I hope is open. Has anybody tried that discussion post? I believe you can start your own threads. Just start a thread with your name and start talking about who you are. And I want to pair you up with somebody. It's unlikely probably that you know somebody in the other cohort already. If you do, that's fine. If you don't, we'll get notified. Okay? So there are a couple of reasons for this. The cohort thing is going to apply to labs as well. So we'll do online safety for lab this week. That's everybody, home and here, both blue and silver cohorts. Everybody will do that virtually. Nobody needs to come into the lab this Thursday. We're going to alternate the way the blue and silver work. And the reason I did that is because of labs. So silver will be in lab next Thursday, okay? To keep you from having to come to campus on both Tuesday and Thursday then, I'm going to switch your lecture day as well, okay? So we will do silver today, blue Thursday, blue again next Tuesday. You guys here in the classroom come in Thursday for lecture next week, right? Do I have this right? Yeah. And for the first lab. Yes? That makes sense? Folks at home, does that make sense? Anybody signed in to collaborate here? I would love for somebody to sign in to collaborate also here. If you have a device, you can do it on the phone also, just to monitor the conversation so that you guys can say, hey, wait a minute, folks in blue are saying they don't have a clue what just happened or the screen just froze or whatever, okay? So please somebody take that on for us. And there's stuff. So anybody see the stuff yet? Anybody signed in to collaborate yet? Yes, Rachel, the lab is online this week. It's safety, and so it'll be the same for everybody. Zach, tell me what did you miss? We good? I think Rachel, is that answering Henry's? Henry, lab, silver will be in lab next week. Blue, this would have been the natural for blue, but everybody is online this week. Okay? That makes sense, Henry? Y'all keep your questions because I don't like this interface of going back and forth, but I don't know yet how I'm going to get out of it, so I'll work on that. So if I don't answer a question, somebody remind me to go check the questions every once in a while. All right, so what I would love to do is have the in-class folks, once we have partners, be your voice, right? So you guys are at home on Thursday. So once you're partnered up, so you're partnered up with little Johnny, right? Who's here on Thursday. And so somebody just posted a question, right? Let's say that's yours, Thursday. Well, I'm going. I'm trying to work on chemistry problems and stuff like that. And you're saying, wait, I'm off. I don't know how you did such and such, right? Then hopefully you have somebody here that's monitoring your conversation, or that you can text, or however y'all communicate now. I'm old, communicate with some of you guys do, I'm sure. But however y'all do that, what's going on now with like, maybe Brittany some? What are the other things now? They're down to Facebook still? I thought Facebook was dead now. I use it now. Okay. All right. That way, so you've got something going on. You contact little Johnny, you're like, stop it. Okay? That way, somebody here in the classroom is like, hold on, there's a question. Okay? That's my plan, at least. That's how it works. All right. So, your syllabus. Everybody can get to the syllabus, I hope. I emailed it out. And grade breakdown. No surprises, hopefully. So look kind of typical. Anybody got any questions about? We're going to talk about the individual categories in that. But overall, 100%, same breakdown as normal. 90% level and above is A, all that kind of stuff. Okay? All right. Homework. What's the purpose of homework? Why do you do homework? What are your thoughts on that? What are the purpose? Right. Well, okay, good. Yes. Okay. Anything else? Tell me what you mean. Yes. Okay. So one other thing I'm fishing for is timing. Okay. Folks tend to get themselves in trouble with, put it off, the exam's not until fourth week, right? So I have an exam on Tuesday, I'm gonna try to cram all the stuff in from these past 3 weeks Monday night. It ain't gonna work, right? Mostly ain't gonna work. You're like those 2 guys that can do that, right? But other than that, it ain't gonna work. So it is a tasting thing as well. Now, if my homework ever becomes busy work, then it's not worth doing, and I should change something. Okay. So my intention is for it to not be. That said, the one that's due tonight is the worst example of that because there are really inane little questions in it, right? Like, who was it that proposed the whole idea? Somebody's up here. Well, so you guys can talk to us in class. That's good to know. So, who proposed the Atomos idea? It's an inane question, but it's mostly to get you used to getting in there, submitting a homework, so you have an easy one to start with, and then it will kind of progress. Okay, the one that'll be due Thursday night gets a little harder, and the one that's due the next Tuesday night is a little harder again. And then the one that's due a week from Thursday will be different. I'll get to that in a second. All right, so you'll notice you might be, right, so if you're yelling at your cat because of something, check and see if you're unmuted, right? Okay. Unless you don't care first, then might be yelling at your cat. I don't know. Okay, so the way these homeworks work, Chegg was a company name, touted as a quote homework help, but the way it really worked is it was a place for folks to go and copy homework, right? It's not doing you any good. I don't care if Chegg can get it right. Okay? Actually, they get it wrong a lot of times. What I'd rather do is I'd rather you get help about it instead of have to go to one of those things. I do understand sometimes. I had a course here at Dalton where I had to rely on Chegg to answer the homeworks. I don't want to be that way. I feel like that I did not get as much out of that course as I might have because I had to do that. But there was some lack in other places. So what I'd rather do, I've got your homework set up right now with 2 attempts on it, okay? Free roll attempts. It's going to count best attempt. So if you go through and make a 20 on it, and then you go through and make a 95 is what's going to count. It doesn't average or anything else, okay? One of the ways you can approach this is to give it a shot and see what you know, and then look and see, well, okay, I made a 20, I think I need to read some more before I do the rest of this. 2 attempts to start with. It does not mean 2 and forever hold your peace. It means that they're set up with 2 by default. If you use those 2 and you're like, okay, what am I doing here? Contact. Let's look at your questions. Let's see what's happening. You're not canceling feet when you do this, right? Okay, cool. And then I'll open up another attempt for you, okay? There is no maximum number. All right, there are a lot of questions. I better go see. Let me answer this before I go look at the questions in the chat. So week from Thursday, homework 4 is a different type. It's an assignment type because I want to see you work out the problem. All right? My intention is for you to take a piece of paper, work out the problems, old school, take a picture of it, upload the picture to Georgia. There are some other ways you can do that. If you want to work it out on a screen or whatever, but I don't want it to be tight. I want it to be like if you want to work it out on a pen with a touch screen or something, that's fine. But I just want it so that you can upload where I see you handwrite it and cancel out. It's about canceling things, is what that is. Okay? All right, I'm going to go get the questions here. Any questions from in class? What do we have? Any questions? Yes, I want to keep the ink, please. All right. Questions here. Zach's answering. Somebody, you guys got any open questions? Anything I need to cover right now? looking at the chat. Anybody, anything? All right, maybe not. I think maybe some folks are already answering for me, and that's awesome. You guys keep doing that, please. All right. All right, so you guys used clickers before? You know what I'm talking about? So the bookstore sells them, and I know a lot of folks here use them. They're so that I could set up a little device here. You got a handheld thing, you answer questions in class, okay? We're going to do that without having you go buy a thing from the bookstore. So everybody try this. Everybody use your phone or your computer or whatever, and that means folks at home too. Go and try this spot right here, right? Now I have a link, and it's also in the syllabus. If there is an app, but I've never tried it, so you guys have to let me know how to do it. But I usually just go through, even on the phone, just go to the website. And you should be able to find an ongoing quiz already in there. Just the first one just says, what's something we should answer in the discussion, and in the introduction discussion. So creative student is correct, Catherine? Hey, Zach, while we're getting on there and doing this, and I'm calling out Zach because I already know him from a previous class. Zach, will you turn your microphone on and let's see how that sounds talking to the class?
Can you hear me?
Beautifully, yes, you come across loud and
Okay,
clear.
cool.
Yeah, thank you. All right, so you know you can do that too. All right. So if I'm not answering a question and it's emergency, like, no, this dude is not making sense, I gotta stop it. Do that. Go ahead and say so. It's okay. Looks like 10 folks have found So Creative. It is going, right? You guys can answer it? Yeah, there we go. All right. Yeah, Rachel's got a good idea there. She posted about if you already know somebody in the class, say so. You guys got a question we can answer for the discussion forum? Anything. It's like like that. What can we answer? What do you want to know about your fellow students and about me? I'm also going to post one, so I'm looking for what you want to know about me. Well, I got distracted by that. I thought somebody had left the water bottle. It's not. It's hand sanitizer. Okay, engineering, this is a terrible idea. Please do not make your hand sanitizer look like water bottles. Okay. All right, we got about 5 answers in. Let's see what else we got. Oh, good idea, Zach. Schedules. Yeah, so if Zach's got calculus on Wednesday, he might want to know if somebody else has got calculus on Wednesday. Or maybe even more importantly, if somebody's got calculus on Tuesday, right, Zach?
What's the room name for the student login?
So, Crisp 958. And that should be the same room number throughout the semester. That's good. Yeah. Okay, cool. All right, I'm going to go on a little bit. That's going to stay open for now. I've got another one in a little while, but I'm going to leave it open and I'm going to keep going some more. What time is it? 8:18. Yep. Pacing is going to be an issue. All right, lab. So I have our planned schedule of labs here, okay? Look on the syllabus, you'll see some of these are in person and some of them are virtual, okay? Especially the last three are online labs. You're not ready to do them yet, but I'll get them up so that you can sometime during the semester. You don't have to wait until the very end. Let's see. Safety. All right, guys. Chemistry lab is inherently dangerous, right? We are going to do stuff with some acids. We are apparently, I'm going to check on this, but apparently we're going to be using the Bunsen burners. So open flame, okay? Please do not catch fire. I do not want you to catch fire. Be safe, okay? I don't know what your former experiences might have been like in labs. If you had some in high school or previously in college or whatever, but just be professional about it. That's the biggest piece of safety, is being aware and professional, okay? Please do not make it happen. I will pull the trigger on tossing folks out of lab, especially for horseplay or something like that. And the very best outcome from that would be a 0 on that lab. Probably going to be worse, but okay. So let's just not. Also, labs should be about learning the chemistry. Okay. If you're not getting anything out of the lab, either you're not doing something right or I'm not doing something right or both. Okay. So let's see what's going on with it. What am I supposed to be learning from this? Is a valid question. Okay. Exams. Gosh, this semester is going to be rough on exams. Okay. I don't yet have a good plan for what I would do if we go all online. Okay? If we happen to go all online, it's going to screw up my plans for exams. Okay? Because, for example, on your first exam, I'm going to have some random question about convert kilometers per hour to nanometers per second or something, right? You just Google that, right? Well, I don't care if Google can get that right. So I need a format so we can test that. Well, if you're in class, that's fine. You know, you're taking an exam, you don't get thrown out and stuff like that, right? Fine, but I don't know how to do that if you're at home. So I would have to totally rewrite, plan it differently. There's apparently a spy on you camera thing that we can use that is with Respondus. Locks down your browser, uses your webcam to watch you and stuff. I don't like that. I don't know if that's my natural inclinations, but I just don't like the idea. So I don't know what I would do. If it stays as currently, what we'll do is week 4, and I don't remember who's first on week 4, probably Blue. So Blue Crew will come in on Tuesday, week 4. Sit down, have the exam like a normal in-class exam, okay? You guys would be at home, right? And I will have a canned lecture. One of the things I did is I placed my exams so that I could best use a canned lecture for that day. So Tuesday, you guys would watch a canned lecture while Blue Crew is taking the exam. And then on Thursday, y'all would come in and take the exam. Blue Crew would watch the same canned lecture at home, and it would be a homework due Thursday. Okay? Plan right now. Also, do you have a calculator? Let me grab mine. Do you have hold up the calculator if you have it right now? I know I can't see you guys at home, but if you have a calculator right now, you need one. It absolutely needs to have exponents and scientific notation. Okay? Your phone is not sufficient because it can't use it on the exam. So have something other than your phone. That's a neat looking one. TI what? 34. I don't know that one. Let's see what everybody's saying about them. Folks are talking about stuff. Let's see. Josh not on. What's going on? Yeah, audio. Okay. Yep. So my wife is a professor in the English department. So she was doing one of her classes yesterday. Our internet had been fine until she started class about 10 minutes in it dropped. I had a conference call and got the COVID antibody test yesterday, just in baseline, because you got girl here, and I don't know if you're affected now. So I went ahead and got one, so I baseline it, and we see what changes throughout the semester and stuff. But as soon as I got on the video call with the doctor, dropped. So I don't know if they have to go home how well my internet's going to handle it. So Josh was talking about his was dropping. Any other questions I need to do? Cheat sheet. Okay. So I haven't gotten to that on the PowerPoint yet. I do intend for you to have a cheat sheet on it. We'll talk when we get to it about the periodic table is the absolute best cheat sheet in all of chemistry. You do want to have a periodic table. We'll get to that one of my last slides tonight, hopefully. Other stuff that you want to put on that sheet. So my intention is, Henry, for it to be a 8.5 by 11 sheet of paper with a periodic table and anything else you want to put on the front or back of it. Is my intent right now. I have not written the exam yet, so that could change, but that's my normal, what I normally do. The purpose of that is I don't want you memorizing stuff. Okay, that's not the world we live in now. Back when I was a kid, there was no internet, and so memorizing certain things, right? Memorizing that helium-4 is the most common isotope, it's got 2 neutrons and 2 protons in it. Those are things, right? You guys don't need to do that so much anymore. So probably some things that are worth memorizing, and I'll try to tell you that when I think this is worth memorizing. But I want you to have cheat sheets, okay? Let's see. Probably whatever you want to put on a periodic table, Henry. Whatever you want to write on that sheet with your periodic table. Haven't written the exam yet, so I don't know for sure, but that's what I expect. All right. Let's go on a bit. Okay. Into the actual chemistry. A little bit of metacognition stuff about chemistry. One of the problems in digesting new chemistry stuff is Johnstone published this about the triangle. So I say to you H2O. I don't know what's in your head. But in my head, there are a lot of things going on. H2O. All right. Well, I know by the symbol that I'm talking about a molecular compound that it has 2 hydrogen atoms bonded to 1 oxygen atom. I actually know a lot more about the molecule because of the way oxygen interacts, the way hydrogen interacts. I can guess at the shape of that molecule. I can guess at the polarity of that molecule, which gives me something about its properties. I'm getting into the representation of this H, the 2, and the O, what it means in a submicro world. Submicro being the atomic scale. That 1 oxygen bonded to the 2 hydrogens, so think about it in space, how it will wiggle different ways. There are different ways it can wiggle. Those matter for properties, by the way. And I'm also thinking macro world. Well, not water, right? I'm thinking about what that looks like. Water doesn't boil as easily as it should when these three atoms bonded together. There's some reasons for that with its polarity and stuff, but that's why we have liquid water on this planet. It's why solid water, ice, floats instead of sinking, and that makes all the difference for life forming. If solid water sinks, like most solids do, I'm a geologist, by the way, so I think in terms of rocks, right? So if you have a magma, liquid rock, and you freeze it into a solid piece of rock of basalt, right? It sinks, and the liquid is denser. If water did that, life would have to do something totally different than what it does. All those pieces are in that symbol to me. When I see H2O, all those things are in my head. So part of your job is to try to figure out which pieces, plural, matter when you see symbology, structures, stuff like that. Not an easy thing, and I get that, okay? I am not offended by you asking stuff. Please do ask, okay? Likely, what you're wanting to ask about, somebody else has too, and maybe hasn't yet, all right? Laws and theories. Somebody tell me usage of one of these terms common right now. How is terms from the scientific method, how are they commonly used now? Hypothesis, theory, law, wild ass guess. I don't know, what else do we use from scientific method? How is something being used? Anybody? If I say I have a theory about how, let's say not me, a random government person says they have a theory about how COVID-19 spreads. What do they mean by using the term theory? What do you think? Yes. So I'm afraid you're right. I'm afraid that's what it means a lot of times. And at least in science, that's not what the word means. Probably a theory needs at least tens of, maybe hundreds of years of stuff to back it up. Or it ain't a theory yet. Okay, what about laws? How does that get to be a law then? And I set you up with a trick question. They're actually separate things. They have no relationship to each other. That's why this splits. This is one of my pet peeves about the scientific method. A theory can never become a law. Because they're totally different things. I have this in my, let's see what the next slide is, whether or not I want to talk about it on this slide or this, or the, yeah. Okay, example. Newton came up with a pretty good law of gravity. The law of gravity says that there is a force that is proportional to the two masses and inversely proportional to the distance apart. Okay? That's the law of gravity. It tells you how fast something will accelerate given its mass. But why? Why does it do that? And this math works. Simple relativity. After Einstein gets involved, this changes a little bit. But before that, that law works. That acceleration works. But why? It's not for sure of why. Einstein came up with this whole warped space-time continuum problem where masses and massive amounts of energy and stuff change it. But it's not for sure, right? All of that stuff is for theory. This law just describes what happens, okay? Not anything about what. So they're totally distinct things. Also, I want to add that if we're doing it right, nothing in science should ever be proven. Give you a little insight into my thinking. Greek philosophy summed up by Axl Rose. Just when you think you know just what you're doing, that's when your troubles succeed. Okay? Nothing should be ever beyond question. Models. There's a little bit of talk now about models. And some folks actually rejecting the idea of a model. Models are how scientists deal with the universe. We make a model and try to get it to work as best we can. This is a model of ballistics, physics, right? So you can decompose your acceleration model and try to see what will happen at a different point. You predict results, and then you test them. That's what science is supposed to be all about, testing your results. But here's another thing. Wrong. Einstein showed us that all of this stuff is wrong, right? Doesn't account for compression of length and time scales at all. So why do we still use it? And I will tell you we do. When I was in the Navy, we did gunfire support based on this physics, right? So does this mean that since my model was wrong, it doesn't take it? We never did relativistic physics when we were trying to shoot a target on the beach. So I should never have hit one, right? Is that how that works? Well, the model was wrong, right? I promise you, we did not do, all of our physics was Newtonian, right? Unless you get into the nuclear program, you don't need relativistic physics. So should I have missed every target because that my model wasn't set up correctly? It doesn't take into account everything? I did miss all my targets, I promise. So what do you think? What's going on? But the model's wrong. How can I get something right if the model's wrong? Thoughts? Anyway. All right, I'm trying to bring you out of the show a little bit. Talk. You guys remember at home that you guys can unmute and talk too. Ideas? Remember that nothing in science is proven. If you have 50 scientists having different conclusions about a topic, at least 49 of them are wrong. Probably all 50 are wrong in some sense. We're always wrong. So you want to use the simplest model that can accomplish your task. Okay? So changing the relativistic stuff on this doesn't change a thing. So if my 15-inch shell misses by 2 atoms, I don't care. I cannot tell even actually, right? So we're going to do that in here. The best model we have right now of the way the atom works, quantum mechanics, wave theory, the way the nodes are set up, stuff like that. But you know what? We don't need it for most of chemistry. It is our best explanation of what's really going on, but we're going to use the simpler models every time we can so that we don't have to do Calc 3 every time we want to calculate an equation. All right, shifting gears a little bit here. Matter. What is matter? Definition here, but it's making any sense. The definition making any sense. What do you think matter? Different energy, yes, okay. What else? What I'm getting to, a big misconception that I've often encountered is, that's matter? Cool, everybody's happy with that. So is this, okay? So different states of matter are still matter. So if I boil all the water out of a beaker, has the mass gone away? What's happened? Say it again.
Matter changed form.
Yeah, it just changed to a different state of matter. How many states of matter are you guys familiar with? Okay, what for?
Solid, liquid, gas, plasma.
Okay, anybody want to add any others to that? There 19, 23, just depending on, what you want to look at. What is plasma? And I don't mean in a medical sense, okay? You gotta make plasma, that's a whole different thing. In a chemistry sense, what is plasma? Okay. So, what is a solid? Say it again. Firm. Okay, what does that mean, firm? Can you touch water?
No, but like, that stays in that same shape.
Shape is very important here. You might want to hazard a guess of that. Use her idea of shape here. How does it work?
The molecules are closer together.
Okay, that's an interesting thought on it. So, but I can compress things really close, right? Does it matter what the molecules are doing
They're not moving around
as much? Okay. So, the standard definition that chemists use is that if you have a 1 cubic centimeter block of a solid in a beaker, you dump it out. Okay? First of all, it stays 1 cubic centimeter, which is exactly equal to 1 milliliter. Okay? So the volume does not change. But also in the case of a solid, the shape does not change. It's still a 1 centimeter cube. That's what we call a solid, is that shape doesn't change. I'm going to challenge that definition some. Zach, Zach, you were in the other geology course. You didn't have the full bore one, but I challenged you in that class about what, the whole idea. We talked about glass being malleable. Solid doesn't maintain. It's all about how well it maintains its shape. I mean, iron doesn't maintain its shape if you hammer it either. So it's how well it does. Just enough. That's why I don't like the chemistry definition so much. Is just in a general sense, if you pour it out and leave it alone, it will maintain its shape. Okay. Liquid maintains that 1 milliliter is still the same volume. Does not maintain its shape. It will spread out. Right? So if I have a beaker and I pour that milliliter in it, what's going to happen? It's solid, it's going to rattle around. It's still going to be a cube. It's liquid, it's going to spread out on the bottom of that, but it's still going to be a milliliter of liquid. What happens to gas? Huh? What? Yes. Okay, so I'm giving you a big hint here. So the solid maintains its shape and its volume. The liquid only maintains volume. The gas,
It's gonna spread out and take over whatever space it can.
so put your definition now in terms of shape and volume.
What does that do? It doesn't maintain shape or volume.
Does not maintain either. Good, very good. That make sense? What's the plasma there?
In between, is it sort of in between solid and liquid?
It's not, that is like a gel form, and that's what I wanted to get to. Thank you for saying that, because that's really what I wanted to point out here. Okay, so solid So I have a solid block of H2O, right? If I heat it, I will melt it into a liquid puddle of H2O. If I heat it some more, I will boil it off into a cloud of gaseous H2O. If I apply a lot more energy to that, I will strip off its electrons and make it an ionized cloud. That is a cloud. Okay? I wanted to get that hierarchy cemented in your head that a liquid has more energy than a solid. A gas then has more energy, and a plasma has a lot more than a gas. Okay? There you go. I should have come to this screen before I started asking that, right? Oops. Why did my block was supposed to go away? It didn't. Okay. You guys know what this is with the Aristotelian alchemy stuff? Y'all heard that at all? Earth, air, fire, water. Well, actually, just said the other way. Earth, water, air, fire. Why did I? That's funny. Yeah. So their idea back a long time ago, was that this is the dense stuff. It was the stuff that formed the terra firma, the base of everything, right? And then the waters would sit on top of that, kind of like an ocean. And the air is above that, and then the fire. This is actually very similar to those four states of matter. Now, that fire part is a little interesting. You had the idea of putting something up higher than the air in order to access this, quote, fire region, right? What would that look like? Oh, not yet. What would that look like? What about this dude flying a kite with a key, right? So I think it's neat that this Aristotle idea was still quite common when Ben Franklin was doing it. He may have been doing exactly this. But it was the model that he had of the universe. This model of the universe, well, we know now it's wrong, but it worked for a lot of things, right? So what's going on? This guy, this random guy, says this thing about earth, air, fire, water, right? And people are like, yep, that guy said it, so we're going to take it, right? Now, the guy in question here happened to be Aristotle, right? So that makes a lot of difference that it's Aristotle that said it. But he was wrong, and everybody listened to him for 2,000 years. So just because someone, certainly Aristotle, right? Just because I say something does not make it right. Challenge it. Okay? You may find the next thing. Don't sell yourself short. But turns out this model, think about all the things that we invented as a species using these bad models. Right? Gunpowder. Early flight, especially lighter than air stuff like blimps. All that's based on this. Heavier than air didn't work yet. Guy nearly tried, but didn't work out. So, Da Vinci. So eventually they made phlogiston as another element, tried to explain some things, but it didn't work out either. So, Aristotle, one of the greatest minds of the ancient Greek philosophers, right? And this random high school teacher named Dalton challenges the entire Aristotelian elements idea. And eventually wins it. Dalton came up with the idea that, look, no, that's not the way it works. If you take this hot water here. You divide it down, right? You have this big chunk and you have two smaller chunks of the same stuff. And you take one of those and you can divide it down. You still have the stuff, right? You keep dividing it down, so you split it down to the smallest fundamental unit. That's that stuff. And we're going to use, turns out he was actually reading Democritus, another ancient Greek. And he used the Greek term atomos for these indivisible particles, right? Well, obviously that's where we get atoms, right? He was talking about, back then, dividing this down to the atom level. Atomos for indivisible particles. We modernized that a little bit, but here's the idea. Take a penny, right? If you can zoom down far enough, and previous times I've taught chemistry and geology, I've always talked about we can't see the individual atoms. Now we have. Just this past summer, we've got, I think it's a development of atomic force microscopy, where we actually see individual atoms for the first time. But you can zoom down until you get to this fundamental level, okay? So we have to stop then, right? We cannot go any deeper than atoms, right? Remember, just when you think you know just what to do, that's when you're trouble succeeds, right? Anytime we say this is a hard limit, probably going to be wrong. We've gone down at least 2 levels below this now. One of those levels we're going to spend some time on. Okay. I'm going to hurry things up a little bit. So notice that all of those atoms were the same, right? They're all copper atoms. But what about if this had been water? Can I divide it all down to one atom? One kind of atom? No, why not? Right, it wouldn't be water anymore. What has changed? And that's because it is not an element. Elements, like copper, right? Periodic table lists them. There are 90 naturally occurring, down through uranium. Anything past uranium, not naturally occurring, well, maybe. There's one now reported plutonium naturally occurring, but I'm not sure how many people accept it. And then magnesium. And there's one other one that I don't remember which is, that were not naturally occurring. But you're right about the water. Some substances, if you divide them down, turns out they're not made of one kind of atom. So this is copper oxide. It's a really, really good kind of copper ore in your mind, right? But it turns out that there's not an atom of cuprites. You can't divide it down because you divide it down and you find, hey, wait, it's actually copper atoms and oxygen atoms. The combination of atoms and how those work then is chemistry. All right, textbook. I should have talked about textbook. You guys all find the OpenStax text? Everybody get that? So I do intend to use it. I know that sometimes you get an online textbook and you're like, well, fine, it's just whatever, it's online, I don't care, right? I do intend to use it. So as you will see just a little bit in tonight's homework, you should be reading in it to get some of the answers. So I do want you to read the text, okay? If you absolutely hate reading the text, I'm putting together, I'm stealing actually, from the E-Core class, some of their lectures where their PowerPoints basically read through the text for you. So you want to consume it that way, fine. Okay, I'm putting those in Georgia View. I've got today's stuff up already, but I don't have tomorrow. I don't have Thursday's up yet. I'll show you where that is if you'll remind me. Okay. When you talk about changing that, you're talking about changing that water in a hydrogen oxide, right? That, you're no longer making a physical change, you're making a chemical change when you split that water. So you want to read about physical versus chemical change for sure. Okay. Law of definite proportions. So, somebody want to see what people are asking?
I said, did you guys the link for the online text?
It is in the syllabus. Let me go back to page. Okay. Oh, it's not here. I thought I put it here. It's in the syllabus, and I'll put a new link up in the administrative stuff if somebody will remind me if I don't do it. One of the reasons I wanted to give you a link is because OpenStax has 2 versions of chemistry textbooks out there, and you don't want to get the wrong one because the chapters will be different. So look at the syllabus if you want it right now. Otherwise, remind me to get it to you after class. Okay. I need to, let's see. I'm looking to open another quiz thing for you. Let's see. And the reason I wanted to pause and tell you that I'm doing this is kind of focus in your attention so that you know that you're about to do one of these questions yourself so that you get in there on the maths. Let's talk about maths a little bit. Yes, you're going to need your maths in this class, all right? So algebra, especially, you're going to need. We're going to manipulate variables a lot. I do it so much that I might do it without thinking about it. Do not hesitate to stop. Wait, how did that variable get over there? Ask me, okay? We'll crunch through the math if we need to. Also, I'm perfectly willing to, I don't have the time in class, but I'm perfectly willing to set up outside sessions to help you, okay? All right, here's some of the stuff going on with Jonathan and what he was looking at with the law of definite proportions. The idea that every time I take copper oxide, every time I break it down, I find the same ratio of copper mass to oxide mass. Let me use a simpler, what do we have here? Hydrogen and oxygen. Isooctane. All right. So I've got isooctane here. If I break down isooctane, I have a certain amount of it. Sample A, I got 14.82 grams of carbon. I got 2.78 grams of hydrogen. If you ratio that, you guys know what I mean by ratio? Divide. You ratio this, you get 5.33 grams of carbon per gram of oxygen. When I use the per, PER, what does that mean, math-wise?
From hydrogen, there's going to be 5.33 grams of carbon.
That's true. But there's a mathematical symbol for per. For PER. What mathematical operation? Yes. That's the division. Okay? So when you say miles per hour, you're saying number of miles divided by number of hours. Okay? All right. Sample B, look, more carbon. More hydrogen, but what happened? You got the exact same ratio. This is what led him to the idea, the law of definite proportions. Always comes out the same. All right. Any questions before we go on to you doing one of these? All right. So same place, everybody already in? Oh, wait, what have I done? No, that's not the right question. We'll get back to it, okay. So the question in Socratic says something about average atomic mass. Ignore what that says and answer this. Same as the last, so we're not doing anything new, right? We're doing that same ratioing we just did on the previous. How long do I have, by the way? Anybody know when classes are?
15 minutes.
Beautiful. Get an answer? Yeah? Put in Socratic? Okay. Folks at home, remember y'all are supposed to be putting in there too. Yep. Good. I know. We have 12 folks answered. Who else are we waiting for? Anybody in here need more time? Folks at home, what you got? Looking at the chat, anybody need more time? Say something if you do, so I can end the other and talk about it. All right, Henry. I have left. All right, we got 3 folks need an answer, so we can go on. There you go, 2 more. All right, so tell me about the answers that we got here. Let me look at them right quick. Okay. All right. So what answer did you get? Somebody tell me what you got. What did you get? Somebody.
Is it just one number?
Tell me what you mean. What did you get?
I think it was like 4, or it was like 4.71.
Okay. Most folks got about 5-1. Should I stop?
And the next number like 0.
All right. So we're going to spend some time on why I hate writing with a mouse. Why did I write this? Why did I write this here? Do I need it? Why do I need it? Yeah, we're going to spend a lot of time on significant figures. Just a preview, so you know that it's coming. We're going to spend a lot of time on why do I need that 0. Shorter answer is because I know it's not 4.511, and I know it's not 4.509. Right? So the 10 tells me that I know that. Okay. So is this the same answer that we had on the previous slide? Look back. It's not. I thought this whole law of definite proportions thing was supposed to be the same number, right? Well, what's happened here? Tell me, what do you think has happened? Give you a hint.
Different amounts of carbon and hydrogen were used.
Say again?
Different amounts of carbon and hydrogen were used in the beginning.
Yeah, but this says, doesn't it, that it should have been the same, right? Exactly. As long as we were still looking at isooctane, but in the example problem, we were looking at propane. So this is one of those examples where a little thing in the question changes everything, right? So propane, as soon as I see the word propane, I already know that we're dealing with this compound right here. And I've got to get you guys to that step. All I need to see is that little word, and I know that structure. And actually, that's a 3D structure. It's a bent molecule. We'll talk about that too. Okay? Okay, if you had a second sample of propane, what would you expect the answer to be? It better be what? It's saying 4.510. And this gets us to the law of multiple proportions. I hate the naming. Law of definite proportions says that if you've got the same chemical, you get the same proportions every time. But if you have a different, you can organize things in different ways. You can combine them differently and get a different ratio. That's law of multiple proportions. We don't really have time to do the example here, but methane would be another set, right? Here I've got 3.75 grams of carbon and only 1.25 grams of hydrogen. So you get 3 grams of carbon per gram of hydrogen, right? But all the methanes will come out the same and still get 3 grams of carbon per gram of hydrogen. All right, some of this, it being 9:09 now, some of this you're going to have to read in the text and try to digest it. Ask me if it doesn't make sense. Thompson shot electrons, deflected them with a magnet. We've got a video up where you can see a guy doing that. This was the idea. Hey, wait a minute. Look, I am breaking off pieces of those atoms I'm breaking some little piece off and shooting it. There's something small. So Jacob Thomson's electrons were the first subatomic particles, smaller than an atom. Then Millikan comes along and he's like, you know what, we can experiment more. We can actually figure out what the charge on that is. And then we can determine the mass of the electron. The mass of the electron turns out to be very small. We'll spend some more time on it later. So they came up with an idea of, here, we've got this atom, right? And it's got these little Thomson's electrons stuck on it, okay? Now, if I were to take and fire something, it's an alpha particle, but you don't know what that is yet, with something small and very fast, fire it at this big wad of material with Thomson's negative electron stuck on it, right? What should happen? What should happen to this fired alpha particle? What should happen to it? Should deflect, should bounce off. Boom! Hits this big thing and bounces back. It didn't. The Rutherford scientists that tried this, and most of his fired particles went straight through without touching anything. The conclusion, experimental conclusion, scientists are supposed to be about running experiments and trying to figure out what's going on. They expected most of them to bounce off, right? A few did, but most of them went straight through without touching it. They came to the conclusion that, well, apparently, most of the atom is empty space. Empty space. So all of that mass is scrunched down right in the middle. I shouldn't do that. Folks at home, I am sorry. I am sitting here writing on showing with my hands on the screen. What I was saying is all of that mass is scrunched down right in the center, with Thomson's electrons orbiting somehow around that little center. That little center is called the nucleus. It's where almost all of the mass of the atom is. The electrons carry the negative charges around it. Later, we will talk about the Schrödinger model. It's the best thing we've got going now. The quantum physics version. But we're going to spend a lot of time on waves and how waves work to get there. Two last slides. All right, periodic table, find one. Glad they finally put these up. But you have one of your own that you get very used to. Okay? But what I expect you to want to have two. I use this one a lot, Web Elements, electronically. Wonderful. You can dive, you can click on Francium. Drop down menus, you get isotope values, you get atomic radius, all kinds of different things. But you also need a periodic table that you can print out and have hard copy and write on. First of all, you're going to want it for cheat sheet, right? But then you're going to want it to get used to it. So that, my periodic table have the atomic number on top of the atomic mass symbol. They do it different ways, unfortunately. Okay? So get one and get used to it. This one works. It's actually a high school one that Georgia used for the EOCTs. I just happen to like it. So it'll work. Remember, you can add to it, anything that you want to add to it, right? And get you a hard copy that you have in your folder that you're starting to make notes on and stuff like that. Remember that homework 1 is due tonight, okay? If you have any trouble getting to it, let me know, okay? Should be easy, and then Thursdays will be hard. I intend to do them every class. Oh, let's see, try it without help first, maybe, however you would like. I don't want you to have to use check. First of all, you have to pay for it. You guys pay for it enough. Use me, you're already paying for it, okay? So get me to answer anything that you don't get. Like, look, I tried this, right? And I got 5 out of 6 of them, but that 6th one is not making sense to me. I read it, read the text, still not getting there. What's going on? Let me know. Let's see, for Thursday, go on to chapter 2. All of this stuff was chapter 1. So we're going to come back to the stuff that's the last part of chapter 1, math heavy, right? We're going to do that. I think we're going to get to that on, hey, am I running late? I'm sorry. We're going to get out of here. All right, y'all let me know. You know how to get in touch with me, okay? Let's get out of Dr. Scott's way. And thank you guys, and I will see you face to face on Thursday of next week, but I will see you online Thursday of this week, okay? Yeah.
Keep that slide.
Say it again.
Send me that slide or share it with me.
So I uploaded all of this, but I'm going to upload a new version.
Oh, okay.
Okay? Does that help? Which side were you talking about?
So will those slides be on the content or on the Georgia View?
Yeah, I'll show you where it is. It's right now. It's under Unit 1, and I'll put the updated version there as well.
Awesome.
Okay.
So we're on Thursday. I know we're on Thursday at 8 in the morning.
Agreed.
Are we for the lab too online? Or-
For this week only, yes.
Yes. So we log on at like 10:50?
Yes,
Okay.
agreed.
Thank you.